C2, integration, example 6. So here we're given a diagram of y equals 1 over x squared minus 1 and the line y equals 3. So for part R, we need to find the coordinates of P and Q. So that's the coordinates where the line y equals 3 intersects the curve 1 over x squared minus 1. So this is using simultaneous equations. So for part I, we are doing, well, we know that y equals 3, so we can just say that 3 is equal to 1 over x squared minus 1. Then we can multiply 3 by x squared, which would give us 3x squared equals 1 minus x squared. Take the minus x squared over to the other side, so we've got 4x squared equals 1. Divide through by 4, which would give us x squared equals a quarter. So of course x is equal to the square root of a quarter, which is plus or minus a half. So that means the coordinate of P is minus a half, 3, and the coordinates of Q are a half, 3. So next we're asked to find the area bounded by the curve and the line y equals 3 and the x-axis. So we're looking for this area here, but if I draw lines straight down, then I can just find the area under the curve between minus a half and minus 1 and a half and 1. So that'd give me these two areas here. And then add on the area of the rectangle in the middle. So the area of the rectangle in the middle, well, this is just a length of 1, the difference between minus a half and a half. And the height, well, this is the line y equals 3. So the height of this is 3. So, for part 2, the area of the rectangle is equal to 3 times 1, which is just 3. So now we need to figure out what the area under the curve is in these two sections. Well, because of the symmetry of the graph, they're going to have the same area. But just to show it, I'll figure out the integration of both of them. So I'm integrating between minus 1 and minus a half of x to the power of minus 2 minus 1 dx. And I'm also going to be integrating between a half and 1 of x to the power of minus 2 minus 1 dx. So when I integrate this, add 1 to the power would give me x to the power of minus 1, and divide by the new power is just minus x to the power of minus 1. And then the same here would just give me minus x, and evaluating that between minus 1 and minus a half. And then the same over here. So that still gives me minus x to the power of minus 1 minus x to the power of minus a half and minus 1. So between minus a half and minus 1. So when I substitute in minus 1 into this, I get so when I substitute in minus a half into this, I get, well, 1 over a half is just 2. So I get 2. Because if we have minus a half, sorry, minus a half to the power of minus 1, then we end up with, well, if we do to the power of minus 1, that's just minus 2, but we have minus 2, which just gives us 2. So that's 2 plus a half minus, and put it in minus 1, we just get 1 plus 1. And here we end up with, when we substitute in a half, when we substitute in 1, we get minus 1 minus 1 minus minus 2 minus a half. So from here, we've got 2 plus a half, which is 2.5, minus 2. So that just leaves us with a half. And here, we end up with minus 1, which is minus 2. Then minus 2, which is plus 2. So that gives us 0. And then we have minus a half, which just gives us plus a half. So the area altogether is 3. So for the total area, we have 3 plus a half, which equals 4. So the total area under the curve y equals 1 over x squared minus 1, and the line y equals 3 in the x-axis is 4.